Let's keep going with these examples. Example B, right away we want to identify it as a difference of two squares, or what the previous video called dots. So dots, or difference of two squares, means that it's something minus something and then the same thing on the other one except with a plus. So that's when we know it's the first term squared minus the last two squared, because the middle terms are going to go away. So we want to get to a point where right away we just see this as y squared minus 4, and we don't even have to do FOIL anymore. That's the idea of this section of special products. It's not that we can't just do FOIL, but it's a shortcut if we notice it has these kind of special patterns, and this one does. It's that difference of two squares where one's plus and the other's minus. Same thing here, right? So in difference of two squares, what we're going to see is we're going to end up doing 5 times 5. And for now, I'm just going to write it as 5 squared. And then the minus sign is always there because it's a negative times a positive will always be a negative. And then it's 2t squared. So we end up with 25 minus 4t squared. And again, we could do FOIL, but if you do, negative 2 times positive 5 and positive 5 times positive 2t are going to cancel. And so that's this special format where it's just going to be the first terms squared minus the last two squared. Difference of two squares. All right, last one before we do somewhere it's a mixture. So this is going to be 8x squared minus 5 squared. Because we have 1 plus 1 minus, the middle terms are going to go away. So it's not that I'm not using FOIL, again, it's just a shortcut. So if you notice, oops, not 6x, it's 64x squared minus 25. So we want to be on the lookout for these kind of patterns to make our lives easier and so that we can get there a little quicker. All right, so let's do some where maybe they're a little more difficult or they're mixed up. In this first one, what makes it more difficult is this 5 out in front. There are a couple different options for what to do with that 5. One is that you could distribute it just inside the first parentheses. It does not go into both, because really this is 3 separate factors all being multiplied. So it's not a distributive property with the second set of parentheses. So one option is distribute it inside the parentheses. But that would make it so I couldn't use my difference of two squares. If I notice that these two factors are the same except one has a minus and one has a plus, we can use that difference of two squares. So it's going to be 2x squared minus 3 squared. And the 5 is still out there, and we're going to have to multiply by it, but we can do so after we use difference of two squares. So we get 20x squared minus 45. And that would have been the same thing as if you distributed the 5 inside one set of parentheses and then used FOIL or the box method. These last two are not difference of two squares. This is now one of those perfect squares where it really is a FOIL problem. So one thing that I tend to see students do that we want to be careful with is that they tend to think, oh, well, when you square this, that would just be t squared minus 5 squared. That's really this one up here. It doesn't work if you just have a binomial squared. You actually do have to multiply it out. You can't just distribute squaring. So let's write that. Exponents do not distribute over addition. That's very important for us to understand. They do distribute over multiplication. So if we had 5t quantity squared, that would be 20, well, let me write it with the distribution. Then I could say, oh, well, that's 5 squared and t squared. But as soon as we have something like this where it's an addition or a subtraction with an exponent, then we need to use FOIL. So there's a big difference between whether the parentheses contain multiplication or division, whether they include addition, subtraction. Addition, subtraction needs to be multiplied out. So now that I've written it like this, it's your choice whether you just like FOIL or whether you want to use the box method. But this -4, again, one option is just to distribute it into the first set of parentheses. Let's do that one. Let's do it that way. So I'm just going to distribute the -4 inside the first set. So that would be -4t plus 20 times t minus 5. So now it's just normal old FOIL, or you can use box method. We take the -4t and multiply by the other two pieces, take the 20 and multiply by these other two pieces. Or if you're feeling like, that looks ugly, there's negative signs, remember you can always use the box method when the multiplication's getting tricky. So I want to do that too. So I have -4t, positive 20, positive t, -5. And we just multiply each term. It does the exact same thing as FOIL, but for some people having this visual really helps them get it right. So I'm multiplying each of the outside pieces. So -4t times t is -4t squared. -4t times -5 is positive 20t. And then I have another positive 20t from those two. And then finally a minus 100. We combine like terms in our final answer. So like terms are the ones with just t to the first power. So our final answer is -4t squared plus 40t minus 100. That's fully multiplied out. And again, there's multiple ways to get there. You could have done the squaring, or meaning done this FOIL first, then multiplied by -4. You could have done the FOIL at this step, box method. But however you do it, this is the final answer. All right, last one that's like this. This one doesn't have the negative sign to mess us up, thank goodness. But again, anytime you see an exponent on addition or subtraction, you have to multiply it out, FOIL, that's it. So this time maybe I'll leave the 3 out. And I'm just gonna distribute or FOIL the inside. And again, if you'd rather, you can draw a box. 4x times 4x is 16x squared. 4x times 1 is 4x. 4x times 1 is another 4x. And then 1 times 1 is plus 1. Just like with the box method, we're always going to have like terms. Maybe not always. I don't want to throw always out there, but usually we'll have those like terms. So it's 16x squared plus 8x plus 1. And if doing it this way, where you left the 3 out, you have to remember to finally multiply through by it. And that's why for some people, they just prefer to multiply the 3 by one of these factors at the beginning, because sometimes it's easy to forget to do it at the end. 3 times 16, I think is 48, I'm gonna say. I'm feeling confident with that. 48x squared plus 24x plus 3, and that would be final answer. And again, there you could have used box method, you could have distributed the 3 inside one of the parentheses. Just don't do it inside of both.